So welcome everybody to this latest video on 162 Maths. In this video we'll be doing the AQA GCSE practice paper higher set 2 paper 2, which is a calculator paper. Now we'll put a copy of a link that takes you to the paper, which I strongly recommend you have an attempt at before watching this video and going through the answers, and I'll also put some suggested grade boundaries in the description below as well. So let's get started on this AQA GCSE Maths higher practice paper set 2 paper 2, which is a calculator paper. So starting with question 1, it says here is a linear sequence and it goes up in 5, 13, 21 and 29. So finding the nth term, we know that the difference is 8. So we're looking for a10. And what do you have to do to 8 to get to 5? Well, we need to take away 3. So we're looking for a10 minus 3, which is our fourth option. Question 2, it says circle the fraction that is equivalent to 0.05%. So what we need to do here is basically on the calculator just enter 0.05 divided by 100, and if you type that in you should get 1 over 2000, which is our first option. With question 3, it says a straight line has the equation of y equals 6 minus 2x. Circle the gradient of the line. Well, the gradient of the line is always the number of x's, and in this case it's minus 2. Then with question 4, it says y is directly proportional to x and k is a constant. Circle the correct equation. Well, it's going to be y equals kx. And then with question 5, it says here there are between 25 and 35 students in the class. The ratio of boys to girls is 4 to 7. How many students are in the class? Well, if we look at the basic number, which is 4 to 7, and we add those numbers up, then that's going to be 11. Then we look at the next multiple, which is going to be 8 over 14. And that's going to give us 22. We then look at the next multiple, so that's going to be 12, and we've got 21, and that's going to be 33, which lies between 25 and 35, so the answer then is 33. Moving on to question 6a, says solve the inequality. So for 2 marks, 1 mark would be to remove the 2, and then we divide by 3, giving us our final answer of x is less or equal to 6. And then with b, again, we just want to expand the bracket, so we get 4x plus 8 is greater than 12. Get rid of the 8, so it turns into 4, and so x is greater than 1. And then with question 6c, it says represent the solution set that satisfy both answers in part A and B. So here we've got that x is between 0 and 6. We can colour the 6 because it can equal 6, and we just have a line that joins those two, and that will be absolutely fine. Then with question 7, it says this formula works out the tax you pay, and T equals the tax in pounds, E is the amount that you earn. It says that Alison pays 5,200 in tax. Work out how much she earns. So for this we've got 0.2 E minus 10,600 all equals 5,200. So what we want to do is solve this. Now probably most likely, rather than dividing by 0.2, which is definitely possible, most people would probably see the brackets and expand them. So we get 0.2e minus, and it's going to be 0.2 times 10,600, which gives me an answer of 2120 equals 5200, and then we simply add this over to the other side, so we get 0.2e equals 7320, and then we simply divide by 0.2, giving us an answer of 36,600, and there we go. For question 8, it says solve the equation. So for this, all we need to do is square root both sides. So we end up with x equals, and it's just remember that it's plus or minus 30.25, which then gives us an answer of x equals either plus or minus 11 over 2 or plus or minus 5.5. Again, remember that it can equal plus and negative, so just make sure that you got that in front. Now question 9 says here are 2 piles of the same type of paper. Each sheet of paper is 7/1000 centimeter thick. The taller pile is 10.5 centimeters high. The ratio of the taller pile to the shorter pile is 3 to 2. Work out the number of sheets in the shorter pile. So for this, what we need to do first is, well, I'd always convert this to 0.0 0.07. And then what we want to do first is, first of all, divide 10.5 divided by 0.07 or 0.7, and that gives me an answer of 1500 sheets in the bigger pile, in the tall pile. So if looking at the ratio, 1500 represents 3 parts, then we want to work out 2 parts, so 1500 sheets equals 3 parts, and that means that 1 part is going to equal 500, and so 2 parts, which is how many parts there are in the shorter pile, is 1000. So the answer then is 1000. Then moving on to question 10, it says here are 4 triangles. Which 2 triangles are congruent? And the correct answer you should have is B and C. And the reason for that is because we're using 2 sides in an angle, which is an SAS triangle. Then for question 11, it says describe fully the transformation of that maps A onto B. So we're going from this to this, and you can see here that the shape has changed shape, so it's going to be an enlargement, and it's become a third smaller, so the scale factor is 1/3, and the center, if you join all the corresponding points, is at the origin or at center 0, 0. So all you need to do is, with a ruler, join this point up with this point with this point, and if you wanted to, for good measure, that point with that point, and you would find that they all meet at that point. And you want to draw your projection lines just to make sure, but I would say you get 1 mark for each of those correct statements. So 1 mark for enlargement, 1 mark for the correct scale factor, and 1 mark for the correct center. Then with question 12, it says the volume of a sphere is 4/3 pi r squared, and it says that work out the volume of a sphere when the radius is 8. So all we need to do is to substitute r equals 8 into this formula. So this is exactly how I'm going to enter it in my calculator, and you should get 2048/3 pi, which would be fine as a valid answer, or if you want to play it safe and play it as a decimal, then we've got 2144.7, and that's been rounded to 1 decimal place. With question 12b, it says 3 spheres of radius of 8 centimeters is packed tightly into a cuboid as shown. Work out the volume of the cuboid. So we know that the radius is 8. So that's 8. So that means that's going to be another 8. So altogether we've got 16, 16 plus 16. This is going to be again another 16, and the height is also going to be 16. So here what we've got is we've got 16 plus 16 plus 16 is going to give me a value of 48. So it's 48 times 16 times 16. And if I type that all into my calculator, I get an answer of 12288. Then looking at question 13, it says in this question all lengths are in centimeters, and it says that given that A to B to B to C is in the ratio of 1 to 2, show that A to C to B to C is in the ratio of 3 to 4. Now with this, what you need to recognize is that when you are converting a ratio into an equals, that you kind of need to flip the numbers. So basically what this is saying is that BC is twice the size of AB. So in order for those two things to balance, I need that 2AB is going to equal BC. So from this, I've got 2 lots of AB, which is 3x minus 9, is going to be equal to BC, which is 5x minus 11. So if I expand the brackets out, I get 6x minus 18 equals 5x minus 11. So x minus 18 equals minus 11. So x equals 7. And then once I know that x equals 7, I can then work out what A to C is. So A to C is 2x plus 4. So that's 2 lots of 7 plus 4, which is 18. And B to C is going to be 5 lots of 7 minus 11, which is 35, minus 11, which is 24. And then writing these two numbers here as a ratio. So here A to C to B to C is 18 to 24, which simplifies to give me 3 to 4, and there is my final answer. Then moving on to question 14, it says a menu has a choice of 3 starters, 5 mains and 4 desserts. How many different choices are there for a 3-course meal option? So it's going to be 3 times 5 times 4, which gives me an answer of 60. So looking at question 15, it says a triangle has vertices at 2, 1, 3, 4 and 6, 1. The triangle is reflected. Points A and C do not move. Circle the equation of the reflection line. So if A and C do not move, then that means that you've got to look at which ordinates do not move. That's going to be Y. And so Y equals 1 will be our reflection line. Then with question 16, it says that the area of a right-angled isosceles triangle is 4 centimeters squared. Work out the perimeter of the triangle in centimeters. Give your answer in the form of A plus B root C. So for this, what we need to recognize is that area of a triangle equals base times height divided by 2. Now the base of this triangle is this, and that also actually is this. We're both the same actually, so we can call that x. So if we call this side x, then what we know is x squared divided by 2 equals 4. So that means that x squared equals 8 and x equals the square root of 8, which I could leave as that, or I could write it in third form, which is 2 root 2. So this length here is root 8. Or 2 root 2, depending on when we have to simplify. Now to work out the perimeter, I also then need to work out what this length here is. So to work this out, I need to use Pythagoras. So here if I call this length, let's call it y. So here I've got y squared equals, and it's going to be root 8 squared plus root 8 squared. And I'm hoping that you would have seen or recognised that why I've done root 8, but to be fair, with it being a calculator paper, it's not really make a difference, just stick it in my calculator. So I get y squared equals, and it's going to be 8 plus 8, which is 16, so y equals 4. So once I know my lengths, what I then need to do is to then work out what the perimeter is going to be. So the perimeter is the diagonal, which is 4, plus one of the sides, which is root 2, plus one of the height, which is 2 root 2. And then joining this all together, I get 4 plus 4 root 2. And there is my final answer. Then moving on to question 17, it says that on January the 1st, 2012, Beth invested some money into a bank account. The bank account pays 2.5% compound interest per year. On 1st of Jan 2013, she withdrew £1,000, and on the 1st of Jan 2014, she had 17,466 in the account. Work out how much money Beth originally invested in the account. So what we need to do here is work in the opposite direction. So as the compound interest is 2.5%, so that means that the decimal multiplier is going to be 1.025. So from January, let's have a look at how much she had in Jan 13. Well, in Jan 13, it's going to be 17,466 divided by 1.025. And that comes up to a total of £17,040. Now she then withdrew £1,000, so I need to add £1,000, and so that comes up to £18,040. And then I need to again divide that then. So in Jan 12, it's going to be 18,040 divided by 1.025, and that comes up to a total of 17,600. And there is my final answer. Then moving on to question 18, it says the probability that Gina goes to the gym on Saturday is 0.9. The probability that Dave goes to the gym is 0.6. Calculate the probability that they both go to the gym on Saturday. So what we need to do here is basically just multiply the two probabilities together, giving us a final answer of 0.54. Then for question 18b, it says if Gina goes to the gym on Saturday, the probability that she goes on Sunday is 0.2. If she doesn't go to the gym on Saturday, then the probability that she goes on Sunday is 0.7. Calculate the probability that Gina goes to the gym exactly one of the 2 days. So if we set up a tree diagram, so we've got Saturday and Sunday, we've got goes to the gym and doesn't go to the gym, goes to the gym, doesn't go to the gym, and goes to the gym and doesn't go to the gym. Now we could see from part A that the first probability is going to be 0.9, which means then the probability she doesn't go to the gym on Saturday is 0.1. Now in the statement it says that if she goes to the gym on Saturday, the probability she goes to the gym on Sunday is 0.2, meaning that that's going to be 0.8. And if she doesn't go to the gym on Saturday, probability she goes to the gym is going to be 0.7. So the probability she doesn't go to the gym is then going to be 0.3. Now what this question is so probability exactly one day is going to be either G and not G, or not G and G. So this is going to be 0.9 times 0.8, and this plus, because that's what or means, plus, and then we've got 0.1 times 0.7. So working this out, I get 0.72 plus 0.07, giving me an answer of 0.79. So looking at question 19, it says that the height h meters of a particle in time t seconds is given by this function. And the question is asking us to draw a graph to show the heights of the particle in the first 10 seconds. So here, what we've got to do is find our values of t and h respectively. So if I start with t, and we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And what we want to do is we want to use the formulas and the functions to work out what h is. Now for values of when t is between 0 and 2, I've got to use this formula here. So basically h equals 0. So plotting these values, I get 0, 0, which is there, 1, 0, and 2, 0. Now for 3, what I then need to do is then use this formula here. So if I substitute t equals 3 into this, then I get the values of 11, then substitute 4 into this formula here. So it'd be 14 take away 4 multiplied by 4 take away 2. So basically it's going to be 10 times 2, which is 20. I then repeat the process. So I then get 27, 32, 35, 36, 35, and 32. And then what I then want to do is plot these coordinates. So at 3 it's at 11, then at 4 it's at 20, at 5 it is at 27, at 6 it's at 32, at 7 it's at 35, at 8 it's at 36, at 9 it's at 35, and at 10 it's at 32, which is there. And then what you then want to do is carefully join these points up. Now again, a bit nervous in terms of doing this on the computer. It'd be a lot easier if I had a pencil and a pen, but that should be a solid line where now I've done dotted, and let me just try and perfect that, and it should look something like that. Then with part B, it then says by joining the points on the graph for t equals 3 and t equals 7 with a straight line, work out the average rate of the change between 3 and 7 seconds. So from this point here and this point here, what we're wanting to do is to work out the gradient of that line. So B is work out the gradient of the line. Now you can do that by using the formula y2 minus y1 over, so the gradient equals y2 minus y1 over x2 minus x1. And if you do that, we get 35 minus 11 over 7 minus 3. And that should give you an answer of around about 6. But you could obviously just from your graph work out the gradient by counting the squares and you'd be good to go. Looking at question 20, it says that in a question, use the conversions of 1 pound equals 0.4536 kilograms and 1 inch equals 2.54 centimeters. The pressure of a basketball is 7.5 pounds per square inch. Work out the pressure in grams per centimeter, square centimeters. Now, these units are really, really important. So first of all, we need to work out that 7.5 pounds per 1 square inch. So to convert the pounds into kilograms, I need to multiply that by 0.4536, which then gives me an answer of 3.402 kilograms. And over, in terms of square inches, I need to multiply that by 2.54 squared because it wants centimetre squared. So from this I get, and I'll put that in brackets, and that's square inches. Now I want it in grams, so then I need to multiply the top again by another 1,000, giving me 3.4, oh, how do I put another 3 there? So giving me 3.402 divided by 2.54 squared. And if I enter that all into my calculator, I should have an answer around about 304 over 6.4516, giving me a final answer of 527.3 to 1 decimal place. Then with question 21, it says the speed of 50 vehicles was measured travelling along a road. Every driver travelling at more than 70 miles per hour is fined £60. On average, there's 8,400 drivers use the road each day. Estimate the total amount of money raised for the fines of road each day. Now the problem is with regards to 70 is that I need to know roughly how many of the 24 that are in the group of 60 to 75 are travelling over 70 miles an hour. So for this, what we've got is if we divide 24 by 15, which is the class width, we get an answer of, and I then multiply that by, and how many are over 70, which is going to be 5. So if I multiply that by 5, I get 24 divided by 15 times by 5, I get an answer of 8. So that means that from this group, 8 are over 70 miles an hour. So the total number of cars over 70 miles per hour is going to be 8 plus 9 plus 4, which gives me 21 cars out of 50. So looking at this then, in terms of this, we've got 8,400 multiplied by the proportion of cars travelling over 70 miles an hour, which is 21 over 50. And that gives me an answer of, just enter that quickly on my calculator, of 3,528 fines. Now, if each fine is worth £60, I multiply that by 60 quid, giving me a huge amount of fines collected of 211,680. Now it then says that Mia says that 4% of the vehicles of road travel at 40 miles per hour or less. Explain why she might be wrong. Well, there's a couple of reasons why she might be wrong. Is because basically we only looked at a sample, so that would be fine. Or another reason could be is that it's only taken at a certain time of the day. On another time, so on another time or day, results may differ. So something along those lines would be absolutely fine. Now with question 22a, it says that x squared minus 10x plus 29 in the form of completing the square. So what we need to do is CTS. Now for this, what we do is we set up our bracket. We divide this number by 2, so that gives me minus 5, and we keep the number, but we take away whatever digit we've written inside the bracket squared, so then it gives me x minus 5 squared plus, and then it's 29, take away 25, which is 4. Then with question 22b, it says the sketch shows y equals x squared plus cx plus d. Work out the values of c and d. Well, if the minimum point is 3, 5, then that means that the equation is going to be this. So y equals that, and if I expand that out, I get y equals x squared minus 6x plus 9 plus 5. And then simplifying all of that, get x squared minus 6x, and then it's going to be plus 14, And so if C is going to equal -6 and D equals 14. So then I can just go down here and write just that. So here I end up with -6 and 14. Then with question 23, it says that 2 triangular lawns are shown. Wire fence is needed on all 5 sides. Wire fencing is sold in 50-meter rolls. And what it needs to do is asking me is to work out the number of rolls needed. So what I need to do is I need to work out what this length here is. I need to work out what this length here is. And I then need to work out what this length here is. And you can say we're then looking at this. Now we know that to find the blue and the purple line, I need to use SOHCAHTOA trig because it's a right angle triangle. So if I find the blue line, that is my adjacent, this is my hypotenuse. So the blue line equals, and it's going to be cos 40 equals, and then if I just call that A over 100, so A equals 100 cos 40. So if I write that in, so 100 times cos 40, it gives me an answer of around about 76.604. And I'm going to give my answers to 3 decimal places. Then for this purple line, which I'm going to call O. So here we've got the purple line, which is cos 40 equals O over 100. So O equals cos, well, let's do 100 times cos 40, sine 40, that should be. Now I've put that there. And let me just get rid of that. Sine 40, and we get an answer of 64.27, and it's going to be 9. So now for this one, what I then need to do is use the cosine rule. We're going to use the cosine rule. Now if I'm going to call this x, so we know that this is therefore going to be my B, this is going to be my C, and this is going to be my capital A. So using the cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A. So we get that x squared equals, and then we're going to have 64.279 squared plus 120 squared minus 2 times 64.279 times 120 times cos, oh, don't know, I put 2 C's there, times cos of 30. So typing that all in, so 64.279 squared plus 120 squared minus bracket 2 times 64.279 times 120 times cos 30 equals, and so x squared equals 5171.6505. So x therefore equals the square root of that, which gives me an answer of 71.914. So this length here is 71.914. So working out the total perimeter, it's going to be 100 plus 76.604 plus 71.914 plus 120 plus 64.279. And if I enter all of that in my calculator, 100 plus 76.604 plus 71.914 plus 120 plus 64.279, it gives me a total perimeter of 432.797. Then it says that fencing comes in 50 meter rolls. So if I divide that by 50, I get an answer of 8.65594. So how many rolls are going to be needed? So 9 rolls are needed. Then moving on to question 24, it says the community frequency diagram shows the times taken by runners to complete a half marathon. And the question is asking, on the grid opposite, draw a histogram to represent the data. Use the table to help you. So what we need to do first is work out what the community frequency values are at each of these values. Now, if I do that correctly, I should have the following values. So I should have 8, 56, 100, 110 and 120. So then from this I can then move on to my histogram grid. So for this, the first one is going to be 8. So to work out the frequency of 100 to 120, I take away 56 from 8, which gives me 48. I then do 100 take away 48, which gives me or those two added together. So 8 plus 48 is 56. 56 take away from 100 is 44. And then going to do 110 take away all those green numbers, which gives me 10, and then the difference then is also going to be 10. So from this I then can work out the class width. So it's just a case of taking away the upper bound from the lower bound, so that's going to be 20, 20, 40, 40 and 100. And then from this, to work this out, I can then divide these two numbers to get my frequency density. And the frequency density values I should have should be 0.4, 2.4, 1.1, 0.25 and finally 0.1. Now from this, what I then want to do is plotting these against these 5 values. Now, when plotting your histogram, you have got a blank sort of vertical axes, so you've got a bit of free rein as to what you want your scale to go up to. Now, because obviously it goes up to 2 decimal places, you may want to go up so that each big block represents a half. So that's going to be 1, that's going to be 2, that's going to be 3. And remember that the ones that you're going for are 80 to 100 is equal to 0.4. 100 to 120 is 2.4. 120 to 160 is at 1.1. 160 to 200 is 0.25, and 200 to 300 is at 0.1. So if you've used this scale in which you're going up, so every big one is going to represent 0.5, then what we then need to do is just plot this. So this will be the biggest histogram you can fit in the scale, I would say. So from 80 to 120, and let me just try and plot this correctly and accurately as I can, just to show a bit of good practice. So let's just load up a square. So I'll sort the axes out in a second. So this has got to go up to 0.4. So that's just 1 less there. And if I just make that like so and just drag that down, it's probably quicker if I do it freehand. But hopefully this should resemble what you do. Then 2.4 is up here. So it's just 1 shy of 2.5. Actually, it should be 2 shy, but there we go. And like so. And let's just move that down to there. And this one actually should be there. And then for the next one, we're going to 1.1, but stretching it from 160. And so 1.1 there. Drag this out like so. And then the next one is at 0.25. Which is a quarter. It's about there. And then the last one, which is at 0.1, which is 2 squares up. And that is roughly about there. So that's what your histogram should look like if you have used this scale. Again, what you could have done is, if I just get rid of all of this, is you could have used a scale of where that's, I'll say that's going to be 1, that's going to be 2, and that's going to be 3. So each little box represents 0.1, and then draw your scale there. But as long as your first bar is going between these values, so it's 0.4, the next one is 2.4, then 1.1, then 0.25 and 0.1, then that is going to be absolutely fine. The general shape of the histogram should be the same. So let me just quickly do this, because it shouldn't take that long. So 0.4 is about there. Then the next one is 2.4, which is about there. Then we're looking at 1.1, which is there. Then 0.25, which is there. And then 0.1, which is like a very thin slither. And there we go. And that concludes the end of this paper. So I will put suggested mark grade boundaries in the description below, so you can see that once you've marked your paper, what grade you could realistically say you've attained on it.